Continuing on with factoring through common factors, we can have common factors that aren't just coefficients or variables. We can have common factors that are entire polynomials. So as long as it exists within each of the terms, then we can consider it a common factor. If I'm looking at example 1, then anytime that I have these brackets here, it's two things multiplied by each other, which means that each one of these is actually a factor. And we can see, when we look closely, that here's one factor that matches the factor over here, and there's two terms that are separated by this minus in between. Which means that I could pull out the common factor of x plus 7. Now when I do this, I'm going to do the same thing that we did in the last lesson, where I'm going to take what is left over when I divide this out, taking away the x plus 7 from both parts, and then put in brackets and state that that is its own binomial result, where I'm going to combine the 4x and the negative 3. I can do the same thing in the next set. I can see that if I have 7 times 3 minus 2y plus 2y times 3 minus 2y, the 3 minus 2y is the same in both cases. And I have 3 minus 2y is what I'm factoring out, and then I'm going to group together what is left over into its own brackets, 7 plus 2y. When I get to the third example, same idea. I have the 4a plus 1 and the 4a plus 1. Now when I divide that out, and I divide it from the first polynomial here, then I'm left with the 9a. The thing I have to be careful of is when I divide it out of the second term, well, there's nothing here but the 4a plus 1, and anything divided by itself is always positive 1. So don't forget that plus 1 there. For part 2, when it says factor the following and write the answer in the simplest factored form, we're really just doing the exact same thing that we did in the last case. We're looking for a factor that's common, and we're going to factor that out, and then we're going to group together what is left. Well, here I have the 5y plus 1, and then it's plus, and I still have the 4y here. Well, I can simplify this because in here I have the 5y and the 4y I can now group together. And say that's going to be 3y plus 2 and 9y plus 1. When I get to example B, there's a couple things I need to account for. They both have a common factor of a minus 6, but they also have a common factor of 3, which means that I'm going to pull out the 3 and I'm going to pull out the a minus 6. And then when I do that, the first term leaves with a, and the second one, when I divide that 9 by 3 as well, is going to be minus 3. For example C, this one is designed to trick you because x minus 5 is not the same as 5 minus x. Say that the value of x was 2. 2 minus 5 would be negative 3, but 5 minus 2 would be positive 3, so it's not the same thing. Which means that we need to rearrange the order. Well, for 5 minus x, that is the same as negative x plus 5. Now, if I want to change this and change the signs for both of these, I'm just going to divide it by negative 1. And I'd be left with x minus 5. It's going to flip the signs on both of these. How would that apply to what I have here? Well, if I want to change the order and pull a negative out, it's going to change what this sign is here. Which means that I could say this entire thing is the same as 2x and x minus 5, and when I pull the negative out, now it's going to be minus 5 and x minus 5, so that I could change the order of those signs. Now I can see that I do have a common factor that is exactly the same, x minus 5. And I'm going to get x minus 5 and 2x's minus 5. Example D, it's the same idea. If I want to change the order in the second part here, and instead of having it 3 minus x, have it x minus 3, then that means that I'd need to pull out a negative. Well, if this is already negative, then if I take negative 4 and divide it by negative 1, suddenly that's going to become a positive, which means that this is the same as 20x and x minus 3 and positive 4 and x minus 3. And I can see that these factors are the same. And I can see that I could divide the 20 and the 4 by a common factor of 4. Which means that this is actually going to be 4 and x minus 3 is what I'm dividing out. And if I take the 20 divided by 4, I'm going to be left with 5 x's, and the 4 divided by 4 is just going to leave me with 1. Now the extension of this is what we call factoring by grouping. Factoring by grouping means if I factor from the first two terms and factor the greatest common factor from the second two terms, if the result is the same, then I can actually pull that out as one common factor. I'll show you what this looks like. If I'm looking at example A, then I would pull the common factor out of just the first two terms. If I have x squared and 3x, I can divide both those by x. And I'm going to be left with x plus 3. If I factor just from the second two terms, 6x and 18 has a common factor of 6. And I'm left with x plus 3. Well now, just like in the last examples we saw, x is being multiplied by x plus 3, and 6 is being multiplied by x plus 3. So I can divide both these terms by x plus 3, and then group together what's left, the x plus 6. For example B, the first two terms have a common factor of 2x. And when I divide this out, well, the 8 divided by 2 is going to give me 4, and x squared divided by x is going to give me just an x. The negative 2x divided by 2x just leaves me with negative 1. the second two terms have a common factor of 3. And when I divide the 3 from both of these, I'm left with 4x minus 1. Now I know I've done it properly because I have the same factor. So I can divide both these terms by 4x minus 1 and then group together what is left, the 2x plus 3. For example C, the common factor is going to be 4a. And when I divide the 4a out, I'm left with 2a minus 1. Now, for the 10 and 5, I would just have a factor of 5. But if I divide 5 out, I'm left with negative 2a plus 1. Which means that in this case, I'm not just factoring out the 5 because these don't match. To make the signs match as well, I need to factor out negative 5. And then I'm left with 2a minus 1. And as soon as I see that these match, then I know I've done it properly. It's going to be 2a minus 1 and 4a minus 5.